How's life?
Life is exciting. I mean, it's actually never been more exciting, I think. I know you feel it. I know you all feel it in the audience. I'm just thrilled, actually.
Gemini 3 is kind of crazy times at Google, huh?
Gemini 3 has been awesome. I mean, I think it's been, you all know, it's state-of-the-art across essentially all the benchmarks. We're really proud of that. But I think for us, we've been on this 3-plus-year journey at Google. Gemini 1 came out 2-ish years ago. I mean, I think that for me, I'll just speak for myself, I'm always rooting for the underdog. And it was great to be a place where Google was the underdog.
You're always
rooting for the underdog.
Rooting for the underdog.
And it was great to be at a place where Google was the underdog. All of us believed internally. Actually, all of us believed internally. But for us to come to this journey, the race is not, I mean, the race is like inning one, right? But we're proud of where we've come over the past few years.
You should be very proud. It was actually, by the way, you proved the naysayers wrong in some pretty profound ways, because people had almost given up on Google in certain areas, and then all of a sudden they're back, and so it's a wild success, and congratulations to you. Couldn't happen to better people, kind of group of people. So talk to us about your, if I think about one of Google's superpowers, it is probably the most full stack company that exists in the market, all the way from the TPUs that you build to distributed systems architecture, to the, and every layer of the stack, all the way to the applications that touch the user and the consumer at scale to billions of users. How much of that is actually a massive compounding contributor of your success?
It's a great question, G2, and I think that this is actually one of, if not the biggest part. In other words, if you look at our stack, of course, we're proud of our TPUs, we're proud of Gemini, we're proud of our distributed systems architecture, we're proud of our data center architecture, our power delivery mechanisms, et cetera. But the real, I would say, a secret weapon that we have is that we get to work together across the stack at the company to solve the end problem. That's what is actually most gratifying. So if you look at TPUs, they're not designed in isolation. They're co-designed with DeepMind, but also taking input from all of the different use cases: search, ads, YouTube,
Do you
cloud.
work very closely with Demis on this on a regular basis?
One of the best parts of my job is working with Demis very closely. And if you look at it, the infrastructure and the models, I mean, we're in this great, challenging, but great place where we wind up being the limiting factor in terms of what the company can deliver.
You being your team because of the infrastructure and how fast it can go.
Of course, I hope that we're also appreciated.
Yeah.
But it is, I mean, in other words, if we had more, it would be a positive. It would be a big positive. So yes, Demis and I speak regularly. Our teams engage deeply. So it's this co-design process that is so important for hardware in particular, but also for software. I mean, the kinds of software that we're building today, they have 2-3 year lead times. The hardware has, as you well know, 2-3 year lead times. So the ability to predict the future, working hand in hand with the research teams that are developing the models and ask and be able to answer, where are things likely to go? Of course, no one can predict the future that far out, but if we know what the probability distribution function looks like, what the Pareto of outcomes looks like, then we can actually evaluate designs relative to one another, looking at to what might be most likely.
And so let's talk about TPUs, because I think it was, it's the first kind of massive success of XPUs that has happened, and you folks have done a fantastic job on making sure that you're changing the scarcity model of GPUs to some degree, and especially on the inferencing side. So walk us through what happens on the, firstly, do you sell TPUs to, will you sell TPUs to the open market, or are you going to keep it within the GCP domain?
TPUs are a GCP product offering entirely, but I do want to note that NVIDIA and GPUs are a huge GCP product offering. In other words, for us, what we're focused on is solving customer problems. And deep partnership with NVIDIA, a lot of our success at Google has been as a result of that partnership with NVIDIA and GPUs. So what we're focused on is solving customer problems, whether internal or external. And there may be situations where one product is more appropriate than another for a particular use case. So that sort of vertical integration, that whole stack solution that you talked about, starts with what problem is the customer trying to solve. And then we work our way up and down in order to deliver, ideally, of course, the best solution with whatever it is that we put together. So for me, actually, the most exciting part of this is how we're able to specialize. In other words, for me, whether it's GPUs, TPUs, product offerings from many, many other companies, and actually it's exploding, as you well know. The real phase change here is actually now we don't have to have general purpose, one-size-fits-all architecture anymore. And we're able to specialize for the individual use cases and even invent wholly new architectures, hardware or software for it.
Do you see that for every class of model and for every variation that you could actually start to etch different silicon that's optimized for that over time, or is that?
It's a fantastic question. It's a fantastic question, and as we know, the more you specialize, the more efficient you can be for a particular workload. Now, actually, the biggest thing that the answer to your question would be yes, if we could only cut down the lead time of hardware design to delivery by a factor of 10. Like right now, today, from the time we say, hey, here's an amazing new piece of hardware, to the time where we have it at scale in the data center, not quite speed of light, but really fast, would be 3 years.
Yeah.
Predicting.
And what do you think that gets to be in a 10-year period?
Yeah, so in a 10-year period, I think I don't know where it gets to be, but if we could, in a 10-year period, get that down to, let's say, 3 months.
Oh, wow.
3 months.
That's aggressive.
You know, I don't know how to do it. Right? I don't know if anybody does. But if we could get it down to 3 months, actually, from a efficiency, capability, change the world perspective, it would be a radically different place.
Would that make consumption really hard? At a 3-month cycle of chips, how would you, because the entire value chain has to shift, right? Because the way in which you actually incorporate the chips in the data center, your capacity planning, how you actually get that to the next, because your shelf life and the amortization of those chips still needs to be, 3, 5, 7 years.
Well, so this is, it may need to be 3, 5, 7 years. I don't think that 6 years or 5 years or whatever we have encoded right now is a law of nature in terms of what the depreciation cycle would be.
And are you saying that that'll be programmability based, or is it going to be actual, like you'll have different tape outs every 3 months?
Well, so that's the key question. I would imagine that you would need different tape outs. And if it's programmable, then it's not going to be specialized.
Right.
And if it's not specialized, it's not going to be optimized for a particular workload. But so 3 months is radical.
Yeah.
I don't know how to do it. 2 years seems achievable.
That's a third of the time. Yeah.
Right, and then now, okay, 18 months. Okay, many people in the audience are starting to get nervous. Maybe that's impossible. 12 months seems not doable. But the point here is the more we can pull it in, the more we can specialize. The more we can specialize, the more efficiency we can deliver. And so in other words, if you think whether it's power, if I can deliver something that is 2x, 5x more power efficient, because I've specialized it for a particular workload. In other words, whether it's GPUs or TPUs or your other favorite accelerator, for a particular workload, power efficiency is at least a factor of 10. Now, okay, what if I had something that was even more specialized? I would imagine actually a factor of 10 is achievable. But then I'd have to predict the future 3 years out.
So how do economics change with XPUs?
So again, I think it's this factor of 10. Factor of 10. And again, picture of XPU, by the way, I include GPUs to me, and I know there's different terms, et cetera. But to me, specializing the way that we have right now gets you a factor of 10, at least. And that might be cost, that might be scale, that might be power across all dimensions. I get that massive uplift, but I give up generality. I wouldn't go run a database on an XPU correctly.
Space.
The final frontier.
Talk about data centers in space, and we talked about it with Matt Garman earlier. Talk about your point of view on that.
It's really exciting, actually, and as probably you're aware, Google is looking into the space. A number of companies are looking into the space from, no pun intended, from a first principles perspective, it holds a lot of appeal. I mean, a sun-synchronous orbit with 24/7 solar power.
Is cooling figured out in space?
Yeah, so I'll get to it. Power. Part of that, by the way, 3-year hardware perspective is actually being able to deliver the building and the power necessary to hold that chip. So we can talk about, hey, if I can go build the chips in 3 months, how am I going to house it all? So removing a bottleneck, which is perhaps, if we can solve all the issues, to be able to put XPUs, GPUs, TPUs, whatever it is in space with 24/7 solar power, no need for batteries, I mean, no cloud cover, right? No sunset, et cetera. Now, okay, cooling.
And you're 30% more efficient and
30% more efficient networking, like actually assuming that we're going to connect these satellites together in space, you get a 50% reduction in latency for speed of light, not having to go through fibers, et cetera. Now, there are many, many problems to solve. Cooling is one of them. Maintenance is another one.
maintenance.
Right. In other words, these computers, accelerators, are wonders of nature. And at least on our side, we're certainly expending effort in maintaining them. But I view this.
I think robotics in space would be the way to do it.
So yes. So if you look at the scale at which we're growing, whether it's terrestrial or in space, I do believe that the current way that we're going about deploying and maintaining our infrastructure is unlikely to scale. And it's unlikely to get to the level of reliability, velocity, and everything else that we need to do it. In other words, I think the way that we're deploying infrastructure today is not radically different from how we did it when, let's say, Google built its first data center in 2002 or so. And that was a 10 megawatt.
Right.
And I remember when this happened, people said 10 megawatts. Right? That now, of course, is people are talking about 10 gigawatts like it's a done deal, et cetera.
Like
so a factor of 1,000 really means that you have to reconsider how you do everything.
You think a gigawatt in space is a decade away?
This is a good question. I think that it is greater than 5 years away at this scale, but it is too early to put a time frame on it, is what I would say. I think that it is an idea that is absolutely worth investing in and going after with gusto, right? Because we're going to learn a ton from it, and I think that it's going to advance the state of the art no matter what.
What do you worry about the most right now?
It changes by the week. It changes by the week. And
velocity is what you worry about.
Velocity is the generic one that cuts across everything in terms of how we're able to do things, how we're able to deliver, how we're able to iterate. Energy will be on the list in many cases, in many weeks. Supply chain, I mean, that the rate that we're all looking to grow, the number of things that we discover.
What do you think of memory prices? Cheap, you think?
So that's been on my list of worries in certain weeks as well. Very, very exciting times in terms of, especially as you know, the split between DRAM and HBM.
Yep.
And how that affects.
Do you see a light at the end of the tunnel? Or Lip-Bu was saying it's going to be until the end of 28.
Lip-Bu would know more about it than I do, so I think that I hope he's wrong, but he knows more than I do. So I think we might have to pencil that in.
Where are the constraints and the bottlenecks going to be in the next couple of years? And by the way, actually, let me take a step back. Things that are absolutely held beliefs of truth right now that you fundamentally disagree with.
I think that one of the things that a lot of people are counting on right now is efficiency winning the day, whether that's software efficiency, model efficiency, hardware efficiency. We're investing hugely in all these domains, power efficiency. The amazing thing right now is as our capabilities grow, as these models become more and more powerful, people are doing more with them. So in other words, every efficiency we deliver, and it's, I mean, the rate of improvement on the efficiency side, I've never seen anything like it. But it gets consumed and more instantaneously. Because the capabilities, I know you had, Mike, a very interesting conversation earlier. The capabilities that these, not just the models, but now the orchestration around them, agents, coding, so much more are delivering, instantly consumes the efficiencies. So, I mean, I think that a belief or a hope, depending on how you look at it, is the efficiencies are going to save the day. They will eventually, but I'm maybe with Lip-Bu on that might be further out than some people think.
And then if you think about original insights that we don't have in the human corpus of knowledge that AI starts to generate becomes the force multiplier rather than just doing something that we do today but doing it slightly better. Are we now generating meaningful original insights from AI that you feel are going to start to solve really complicated problems, or you feel like we're still a little ways away from that happening?
It's a great question, but I think that to me, it's the more impactful question right this moment is, as a former professor, relatively long-time professor and academic, the question I would always ask myself, and in academia you get judged on the originality of your idea,
Yeah.
which always used to drive me nuts, because for me it was always standing on the shoulder of giants. Like,
Yeah.
was I really original, or did I?
Consumerization of the idea that might be more.
Right, and did you put the right set of ideas together in a way, et
Aggregated them,
cetera?
yeah.
So I think that for me, the most exciting thing about this moment with AI and Gen AI is, even for people like me who are super privileged, super lucky to have access to information, to have access to experts, I'm able to get near instantaneous insights for relatively advanced questions, not original insights. In other words, if I were able to instantaneously contact world-leading experts or top 1% experts, I'm sure I'd get equal or better. But it's at the point now where across so many different fields, I'm able to access incredible information near instantaneously. And so, in other words, even if you look at it from a business impact, I might ask a question at work, and I'm fortunate to have amazing teams. It might take many, many people, many, many days to answer my simple question. Mm-hmm. They're the smartest people, they're working super hard. But now being able to get that same answer in seconds, minutes, without having to consume the time of many smart people, is that original? No.
No, but
is
it's
it a game
actually
changer?
Massively
It's a game
additive.
changer, right? So to me, I'm not so worried about, is AI going to now be able to outdo humanity with original ideas that we couldn't do on our own? Maybe that's going to happen, maybe that's not, or when is it going to happen?
You stitch them well together, you'll actually have meaningful
right this moment, and having access to them.
Yeah.
Right? In other words, I might have a PhD in computer science, very fortunate. I might understand concepts in computer science, but I don't have a PhD in biology, in chemistry, in finance, in medicine, et cetera. But having access to that myself, that I think is the game changer.
And so this is actually a very interesting use case, because if I were to think about what is the most additive use case in my life, it's been research and learning.
Yes.
Right? We talk a disproportionate amount about coding. We talk a lot about customer support. We talk a lot about a lot of those use cases. Research and learning is one that is actually least talked about. It is actually the most used. It is the most prolific in humanity.
Exactly. And
we have actually somehow gotten so used to it that we've stopped even giving it credit.
And I think that's, I mean, the way I like to cast it when I talk to my team is, we have the opportunity, we're not there, and there's lots of challenges. I also heard the discussion on safety, but we have, and security. We have the opportunity to deliver a doctor for every patient and a teacher for every learner, and be able to specialize it to the needs of the individual, the business use cases we talked about as well. So, I mean, this will be a game changer. In other words, as you said, for you, you're learning oriented. You want to learn, you're very good at it, et cetera. Being able to open this up to everybody. And I think we're actually at the cusp of that.
Yeah.
And then similarly, being able to proactively deliver.
Is it already opened up at this point?
I think that it is very, very close.
If you have the internet, you've got it.
If you have the internet, and if you, now I think the last bit that is missing is the personalization. To, in other words, and it's already, we're seeing hints of this.
Yeah.
Right, where, okay, G2, he likes information presented to him like this.
Yeah.
I mean, more or less the same, but a little bit differently.
Yeah.
I think we're almost there, and then similarly, if we could do it for health, if we can do it for business intelligence, et cetera, and it's not as far away as some might think.
So if you were to get people excited about the next few years and what's happening in Gemini 4 and Gemini 5 without revealing roadmaps, but go a little bit more specific, than they're just going to get better as models, which we all know. What do you think we could expect, and what turn of crank can we expect? Is it a 10x better with every model? Is it 25% better? Is it 100x better? And does that improvement compound over time? Or
Yes.
does it actually start to flatten as a curve?
At this point, I don't see any slowdown. And so what I would say is I mean, the capability of the models, it's hard to put numbers on them. But I would say that it definitely feels the same as it did in the heyday of CPUs, Moore's Law. We have Lip-Bu in the audience, where every 18 months, you couldn't wait to get your hand on the latest CPU because everything got twice as good for the same cost. I think that where we are with models every 3-6 months, I don't have a quantification around it, but things feel like they're getting twice as good, even faster than
And do you think our
Moore's Law.
evals are getting better proportionately to actually gauge whether or not the models are in fact improving at the level that we
The evals are getting really good.
They're really-
The evals
really
are
good?
getting really good because I think they're increasingly focused on real-world use. And actually, we have enough data where the models didn't do well in the past. And so we can actually now say, hey, you know what, for these hard cases, the ones where the models maybe struggled some before, they generally do well for many, many use cases. How much improvement do they deliver? So it's hard to say, okay, across all evals, the model is twice as good. But I mean, I can tell you, and it's the same, by the way, it's an amazing time because whether it's Claude, whether it's ChatGPT, whether it's Gemini, they're all getting better. And they're all making I would say the competitive environment's also making everyone better. So this is fantastic to see where release after release, you're feeling like you're gaining more insight, you're gaining more capability. And it's able to go further, deeper, faster.
What question did I not ask you that I should have, and what advice would you give to this audience as well?
I mean, you asked fantastic questions. What I would say is
Oh,
that,
Gemini.
Yeah, well, no, I wouldn't say that actually. But I mean, for me, of course, I love Gemini. I love what we're doing there. But this is very sincerely, this is not going to be a winner-takes-all environment. This is going to be, you all have heard it, the biggest revolution since the internet. I remember the internet. You remember the internet very well. It was a pretty big deal. Like, in other words, I think we're at the point now where those of us who have children, they wouldn't be able to recognize how those of us born before the internet exploded lived. Right? The world is just a radically different place. This is going to be that, but much, much, much bigger. And in technology, there's never been a better time to be working, be contributing, to be making an impact. Whether you're working at the top of the stack or whether you're working in infrastructure like myself, like, of course, all the amazing things that Cisco is doing. The great thing about infrastructure is whether it's the internet or whether it's AI, it's high in demand. So maybe you didn't ask this, but what I would say is the opportunity to write the book for how we support this revolution from a technical perspective, I mean, it's singular, right? And we're going to literally be inventing the future in terms of how these services, how these agents are going to be delivered.
I mean, I have to just thank you. I think it would be remiss if I didn't thank you for all the great work that we've done together as two organizations. And
Absolutely.
I want to see that partnership just flourish over time. And it wouldn't have happened without your support. And thank you for your entire team and how they work with our Silicon team and our kind of our networking team. So really appreciate it. Thank you for being here. Hopefully you'll come back again.
Absolutely. Would love to. Yeah.
Thank you.
Thank you very much.